the blue rectangles there that have been shown in between the lower and upper control limit, these all are variations due to common reasons. And there are a few points which are outliers, or you can say at extreme points, which are coming out of these limits, and these are due to the special reasons. So we can't move further until and unless we will not eradicate this cause and make the process again you can say within limit. So we have to take care, otherwise we will going to face huge losses as far as cost is concerned, as far as production is concerned. So the main thing is that interpretation of charts, how engineers interpret the charts, that's the whole game. Now basically, as I have said, in any control chart we have a center and upper and lower control limit. Beside that, in order to interpret it thoroughly, we have divided the region between the center line and upper control line into three zones. Like along the center line we have zone C at plus minus 1 sigma, and then we have a zone B at plus minus 2 sigma, and then we have a zone A at plus minus 3 sigma. So if these zones they are clear, you can easily understand various rules how we can say our process is out of control. So we have in general we have 5 rules which are accepted internationally. Rule 1 is a process is assumed to be out of control if a single point plot outside the control limit. Say like this, the process is moving, the process parameter is moving well within limit, but here the point is gone outside the upper control limit due to some, you can say, assignable causes, due to some special reasons, and this is the point at which you can earmark that yes, here we need some preventive action, corrective action, so that we can make the process again within limit. And this is the out of control process, you can say. So this is the rule 1, how we can read, how we can you can say predict whether the process is in control or out of control. First rule is when it is moving out of the limits, very simple. Similarly, we have a rule 2. Now a process is assumed to be out of control if 2 out of the 3 consecutive points fall outside the 2 sigma warning limits on the same side of the center line. Now you see here, if you see these red arrows, we have this is the center line, and all the 3 points they are lying on the upper side of the center line, or you can see in between the center line and upper control limit. Now here the 3 consecutive points, out of 3 consecutive points, 2 are beyond this 2 sigma zone. So this also shows instability of the process. You can say yes, process is out of control, or it will going to be out of control after some period of time. We must take some corrective or preventive action right here before any nuisance occurs. So this is the rule 2. Means it is not necessary that process always move when it shows you can say the points are out of control, then and only then process is out of control. The points when they are within the, you can say, upper and lower control limits, still there are rules through which you can predict whether the process is in control or out of control. So this is rule 2. If you have 2 out of 3 consecutive points fall outside the 2 sigma zone, then you can say process is out of control. Similarly, we have rule 3. A process is assumed to be out of control if 4 out of 5 consecutive points fall beyond the 1 sigma limit on the same side of center line. Now again here this is the center line, and we have all these 5 points, they are lying below the center line. So you can see we have 4 out of 5 consecutive points, they fall beyond the 1 sigma limit. Say this is the 1 sigma limit, you can say zone C. Beyond the 1 sigma limit we have 1, 2, 3, 4 and then 5. 5 point is coming right on to the 1 sigma limit again. So we have 1, 2, 3, 4 points which are coming out of 5 points. We have 4 points out of the limit, or you can say out of the zone C, or you can say out of the plus minus 1 sigma limit. So you can easily predict yes, the process is out of control. So similarly, we have rule 4 also to interpret control charts. Now a process is assumed to be out of control if 9 or more consecutive points they fall to one side of the center line. Say if this is the center line, you can see 1, 2, 3, 4, 5, 6, 7, 8 and 9 points, they are consecutively lying above the center line. Now this shows a trend, and this will drift the process out of control limit in further time. So we must take some preventive action right here to make the process well within control. These are the signs, these are the, you can say, the symptoms that we have got from SPC charts to take some necessary preventive action well within time, so that we can reduce our breakdown cost, etc. Similarly, we have rule 5, a process is assumed to be out of control if there is a run of 6 or more consecutive points steadily increasing or decreasing. Now you can see here 1, 2, 3, 4, 5, 6 points, they are consecutively increasing. They may be decreasing, but here in this particular case, the 6 points, they are moving, you can say, on the upsides. You just see the first point is below the center line and the 6th point is above the center line. So you may cross the center line, mean line, you can say. So a process is assumed to be out of control if there is a run of 6 or more consecutive points steadily increasing or decreasing. So this is again a condition for out of control. So these are 5 internationally accepted rules through which you can interpret whether the process is in control or out of control. Now the next thing is the type of SPC charts. Generally there are 2 types of SPC charts we have. It depends upon the data that you need to you can say draw. Say generally we have 2 types of data, like attribute data or variable data. Attribute data basically means data is in counts, and variable data when the category of the control chart display value resulting from the measurement of a continuous variables. When we have continuous readings, for example temperature, for example radiation dose, for example elapsed time, means the data which can vary continually. So it's a variable data. So we have 2 types of data, attributable and variable data. Now depending upon these 2 types of data, we have a spectrum of control charts. Now this is the slide which I think shows the criteria which must be taken care of as an engineering student as well as industrial practitioner, that what type of SPC chart you should draw for what kind of condition. Say what type of data you have. If you have a variable data, go to the left side, then you just see the subgroup size, available subgroup size. If the subgroup size, or you can say the lot size, is 1, then you can draw individual and moving range chart. We call it as I and MR.